Today's topic is human health monitoring using gait analysis through wearable device as body area network. Sir? I think your audio is not connected.
Ma'am, now I'm audible?
Now.
Okay. Thank you. So, should I start?
Yes, sir. You can share your piece.
I'm sharing. Okay. So you can see my screen now.
Yes, sir.
Okay. Thank you. So thank you, ma'am, for a nice introduction as well as giving me opportunity to speak. And especially, I would like to thanks Department of EC, SV's College, Andhra Pradesh, for giving this opportunity and for providing the FDP on the design on the wearable sensors. So my talk, the topic of my talk, as already madam has discussed, it is human health monitoring using gait analysis through wearable device as body area network. So body area network is widely known as BN. And good morning to all the participants. If any moment of time, if they will have any doubts, they can ask. I'm continuously looking in the chat box also. They can write in chat box also for any doubts if they are finding any difficulties. Okay.
Okay, sir.
So, okay. So now let us understand each term. First, human health monitoring we have to do. So obviously we require some sensors. Okay, some sensor by which we can predict, we can assess the health. So that means we can measure certain parameter values through the sensor. And here I'm using GAIT, gait. That means gait means walking pattern. How human being used to walk, that is what gait. So gait is somewhere it refer as locomotion, somewhere it is refer as a walking pattern. So different people has its own way of walking. Okay, you have seen that it is very unique biometric identification, like face, palm. It is also very unique biometric identification. It is biometric, behavior-based biometric we used to consider. So with the help of gait, we can not only uniquely identify person, we can assess the health. If any neurological disorder is going to occur, after stroke, the person are suffering with their walking pattern or freezing of gaits, such kind of disease, we can identify. Even we can monitor whether you are some abnormality is going to happen with you in the future. So we can assess your walking pattern and we can identify some abnormal walking pattern is going to develop. Okay. Then I will introduce you wearable devices as well as some other sensors also, by which we can capture the human walking data and we can apply for human walking using the as a body area network. And last, I will introduce how this can be fit over IoT or cyber physical system. Okay, so this is biomedical signal processing application also you can consider. Already introduced myself, Dr. Vijay Bhaskar, and working at Department of CSE, MANIT, Bhopal, and working as visiting faculty also at IIT Bhopal as well as IIT Gwalior. Okay. So now moving forward, I'm coming on my talk. So gait already I told that it is locomotion or walking style. And due course of this presentation, you will understand gait in the depth. What is gait? Different animal has its own different gaits. If you are referring for tiger, then it has different gait. If it is human being, then it has different way, and different people has different style of walking. I will quantify or I will define locomotion also. Locomotion is just you are moving from one place to another place with the help of two legs. Okay, so if it is human being, then it is two legs. If it is animal, then it is four legs. If it is some mammal reptile, then they have their own more than two legs they will have. They used to perform their walking. If it is bird, it is flying in the air. If it is fish, it is swimming in the water. So that is what locomotion. So human gait refer to the locomotion achieved through the movement of human limbs. Limbs mean left and right leg. So with the help of two limbs, whatever the motion or locomotion you have achieved, that is referred as human gait. And the human gait is defined as bipedal. So bipedal and robotics, those who are aware of robotics, bipedal means which has 2 legs. An entire human architecture, human infrastructure, our infrastructure is designed for human being, whether it is staircase, railing, bed, chair and sofa, all sort of things are designed for the human being. So we are looking for such a machine which can have similar capability of human being. Okay, so that's why human gait is defined as bipedal. It is biphagic. It is divided into majorly 2 portions, and for your reference, I'm first bringing that diagram. If you can see, there are some states: 1, 2, 3, 4, 5, 6, 7, 8. 8 discrete states are there. When you are talking about human gait, there are 8 different states are there. Okay. And broadly it is dividing. If you see that there is dark black leg and there is slow black leg. Okay, that is not that much dark, light black. It is coordination of both left and right leg. This is your left leg, this is your right leg. What you are seeing here, each point, I have divided entire walking cycle into 8 phases. Okay, human being used to repeat this gait cycle again and again. If you are performing 1000-kilometer walk, so you are repeating several times this gait cycle and again. Okay, that is normal gait cycle. When you are running, then gait cycle will change. When you have brisk walk, solo walk, all sort of walk you perform, that time it is different. It is biphagic because it has divided into 2 phases. One is stance phase, another is swing phase. The swing phase, when your one foot is in the air. So this time left foot is in the swing phase. Now right foot is in the swing phase. Right swing, right swing, right swing. Momently you will have left and right stance phase. Okay. So swing phase when your one foot is in the air, stance phase when your foot is in the ground. So when left foot is, as you say, left swing phase, the right foot is in the stance phase. That means stance, S-T-A-N-C, stance phase. So I hope that this is clear. It is biphagic. That means it is divided into 2 phases: left swing phase as well as stance phase. So in one gait cycle, we used to perform 3 stances. One is left stance. Second is left plus right stance. Both foot will come into stance phase. And then third time it is right stance. And then you would say different people has defined gait by different meaning. We have our definitions that I will tell. According to our definition, when same foot will contact on the ground again, then I will consider it is one complete gait cycle. Okay. This is hill style, and this is toe off events. When you are going swing phase, so phase is becoming toe off. So when same foot will contact on the ground, then I will assume that this is one complete gait cycle. So it involves different step, left step, right step, left step. From you can see that your left foot is in the air. This is left foot. This is right foot. This is in swing phase. This is in stance phase. So when left foot is in the swing phase, up to this point it is in swing phase. After that it is becoming in the stance phase. Okay. The red color is the swing phase. Okay. So first left foot in the swing phase. After that, what is happening? Right foot is coming into swing phase from here onwards. So when your left foot is in the swing phase, right foot is in the stance phase. This is right foot is in the stance phase. That means right foot is in the ground. Okay. Then again, this particular portion, I'm talking about this particular. Here both foot are in the stance phase, left and right foot. That means both foot are on the ground, and that is referred as double support phase. Before this also there is a stance phase. This is left stance phase, right stance phase. It is again double support phase. After left stance phase is going on, swing phase has finished. This is also portion considered stance phase, and this portion is considered double support phase. So if you say 2%, 2%, 10 to 12%, so hardly you have 30% of time or 20% of time you have double support way. Rest 80% of time you have single support way. And the moment single support way is that only one foot is in the ground, and double support way when both foot are on the ground. And practically you can see that when you are walking, your both foot will not touch the ground. Okay, that is the thing. And due to the swing phase only, we are getting the propulsion so that we can move forward. Any doubt up to this point, anyone? I'm just trying to introduce the terminology defining the gait. Later on, we'll see that how we'll construct the body area network, how we'll measure the gait analysis for health monitoring or other applications. So I hope that this is clear to everyone. So I was defining the gait is defined as bipedal, that means which has left and right leg, biphasic which has swing and stance phase. Further, it can be divided for further subphases. Then forward propulsion, that means there is forward force in the direction so that we can move towards forward direction. Then only you will move. So it is generating swing phase of the center of gravity. So around center of gravity, there is force in the forward direction of human body. So there are alternate sinus movements. That means sinus is here, left and right leg, limbs, left and right limbs. So this is movement of left and right limb of different segment of body with at least expenditure of motion. So someone has defined like human gait is bipedal, biphasic. It has forward force around the center of gravity so that human body can move in the forward direction with the help of alternative sinus. Sinus because both leg are governed by the human brain through the sensory organ. So through sensory organ, we are capturing data, we are acquiring data. That data is going through our sensory organ to our brain. Okay, brain is planning, and then particular motor neurons is learning, and after neurons are learned, they are guiding the motor how to move particular motor action or muscles. Okay, the one thing is that expenditure of energy, and nature is the best source of optimization. Everything which is in the nature is optimized. So better than nature we cannot become. That's why bio-inspired nature techniques, nature inspired techniques as you, and our objective also that whatever, whether we are walking, jumping, or crossing the obstacle, that time we require least energy, that means optimal. Now moving forward, human gait pattern are helpful in identifying the useful inside of the body. What are these insights? Movement, posture stabilities. As you seen that elderly person used to suffer with the walking, their posture disabilities. The person with disabilities also suffering with the posture stabilities. They are not having stable postures. Okay, so these things can be identified through the human walking or gait or locomotion. Okay, the gait already idea. Gait walking involves having at least one foot in the contact with the ground at all the time. When its foot is lifted off, that means swing phase. The limb in the swing phase of gait, and when foot is in the contact of ground, the limb in stance phase. That's why it is considered biphasic. Now, another important parameter is gait velocity. So those walking, you can have step length, stride length, ground clearance, how much you are taking off your leg from the ground when you are moving or you are in the swing phase. So gait velocity, the habitual, because this is behavior based biometrics, so it depends on your habit. So habitual walking speed adopted by the person in everyday life. Medical research has shown that the gait velocity is an important health metrics. Later on in presentation, we'll see that what health metrics it can measure, what kind of analysis you can do through the gaits. Okay, we'll see that because the gait is the learning process, walking is the learning process which human being used to acquire through continuous interaction with the environment. The motor used to learn, and the motor used to govern our muscles or other movements. Okay. Now coming on the health monitoring. So when you are performing walking exercise, that means you are doing walking, it involves your nervous system, that means brain, cardiovascular related to heart, pulmonary related to stomach, and musculoskeletal, where muscles and the joints are going to involve, and hematology systems. It involves this one during exercise, and it requires more oxygen to perform such task, to contract the muscles. To contract the muscles, we require oxygen. So during walking, we used to tire because we are consuming, and our breath cycle will increase also, because oxygen we require, because this involves oxygen. And if you are taking oxygen, that means it is certainly very beneficial for human health. The question is coming, if impairment of any of, whether it is nervous system, cardiovascular, pulmonary, musculoskeletal, hematology, and I told that the gait or walking involves all sort of things. So at least you can identify the abnormality happening in these systems, which I define. Okay, so impairment in one of these systems impact the person gait velocity. It can affect your walking. What is happening after cirrhosis, multiple cirrhosis, paralysis, stroke? The person are losing his walking abilities, his cognitive abilities. Due to cognitive ability, obviously you are losing. Many times due to the side effect of medicine. One of the patient I have seen that which have consumed the drugs, and later on due to the side effect of drugs, he become totally paralyzed and unable to walk. It took almost 3 years to recover his walking pattern. So it's such a dangerous effect many times happening due to the overdose of medicine. So always prescribe through the doctor and use the medicine. Okay, don't treat yourself by the things. So that's why the physician has called gait velocity a better predictor of various health issues. So you can see that when sports person are playing, and they are generally suffering with the hamstring and other kind of stretch kind of problems they are seeing when they are playing or doing excessive exercise. Okay, or injury happening due to the accident or something. So many times we have to perform the operation also. So post-operation, pre-operation also we are losing our walking pattern. So you can understand this is not ordinary things which I am talking here. It is very much related to human health. And the gait velocity is considered the parameter by which involve the nervous system, cardiovascular, pulmonary. That means obviously this is helping us to assess these systems. That's why for this study purpose, I've considered human walking analysis for human health monitoring. Now let us little bit see two important capability as human being, locomotion, and how we define the locomotion. You can see that this is walking capability. The person is walking with the nature, and this is actually not person, it is model, dummy model, robotic model, which has certain degree of freedom, hip joints, knee joints, ankle joints. I will demonstrate certain software also in which you can see the different degree of freedoms, other things, but this is define the locomotion. With the help of left and right leg, you are moving in the forward direction. Okay, your joints are moving with a certain degree of freedom. Okay, so I'm not going to answer this one, why bipedal, why push recovery, and another behavior is push recovery. That is also very important parameter of human health assessment. So some external force is coming from forward direction, and due to degree of freedom of mobility at hip joints, knee joint, and ankle joints, you are able to recover from external forces. Okay, so how good your training, how human beings used to learn? They used to learn through the trial. Continuously they used to practice and try to improve that particular behavior. If you want to become the javelin thrower, a world renowned popular sports person, you have to do practice high enough. So practice is required. Through practice you can learn the behavior. Okay, that's why athletes have better post recovery and locomotion capability compared to the normal human being. Okay, so these behavior, learning based behavior, we are acquiring through environments. Okay, and we are looking for a study of locomotion, for especially to design the artificial limbs, prosthesis leg, to understand the human monitoring system, assist the elderly subjects so that they can walk perfectly. Okay. So now you can see that what is wearable sensor. The sensor which you can wear over your body, that is considered wearable sensor. Okay, wearable sensor. So if you see that the image, left hand side image, we have placed camera phone, mobile phone, cellular phone, and you can consider mobile phone. Other place I'm using some sensor. These are IMU sensor. That I will tell what is IMU sensor. Inertia measurement unit sensor. Okay. Actually, this is 9-degree IMU sensor, 9-degree of freedom IMU sensor. Out of these 9-degree, 3 degree for accelerometer. If you have any doubt, you can ask what is accelerometer. 3-degree for gyroscope and 3-degree for magnetometer. Accelerometer is used to measure the acceleration around XYZ axis. The rotation can be measured by the gyroscope, and magnetometer again used to perform similar tasks which accelerometer and gyroscope. So effectively you can use in 6-degree of IMU sensor. Acceleration, when you are moving in forward direction, it will measure the acceleration around your that particular direction, and orientation can be measured by the gyroscope. So any device on any IMU sensor has this capability. Apart from their mobile phone is quite handy. You can put in one packet. You can place, like I have a place there. The subject is performing walk over the unconstrained environment. That means it is not laboratory environment. It is outside laboratory. The person is walking, and we have placed the mobile phone. And we know that in mobile phone, what is there? Mobile phone now they are automatically enabled with the accelerometer, gyroscope, and you can download physics toolbar accelerometer that I'm going to show you. Physics toolbar accelerometer. Okay, this app physics toolbar accelerometer. You can download this app. Okay, Android app, and you can see the capabilities, what it is doing. It is measuring the acceleration. XYZ axis.
Top, reading about a g-force of 1 in the z direction, and you'll notice 2 other lines near the bottom, near g-force of 0. That's the side to side and forward to backward dimensions.
What is happening? You have 3 axes, X, Y, and Z. X is represented by red color, Y is represented by the green color, Z is represented by blue color, and that is measured in the g-force. And the beauty of this app, which you will use, physics toolbar accelerometer, you can refer my paper. I will share my research gate profile. You can follow there, and then you can refer my papers also there. The G force is 9.8 meter per second square. The force. So it depends on, as you move from the earth to some other surface, your accelerometer value will change. So there is drift. That's why we used to put magnetometers. The accelerometer you can record in the G force. Okay, on either meter per second square. Gyroscope will give you degree per second or rotation per second, and magnetometer is micro Tesla you are only. So maximum range is allowed +4 to -4 g force. In between you can do with a little bit drift. You can see that so far the walk is very ordinary. There is no movement. But the
gravity, as you know, pulls down towards the center of the earth, which in this case is along the z-axis. If I take my mobile device and I decide to shake it in one dimension.
So now device has shaked. That means the accelerometer, you started performing walk. So when you will perform the walk, then you can see that there is spike in the curve, which you are finding accelerometer data is you started capturing XYZ. There is some noise.
Primarily, you'll see it shakes in all dimensions. Really, it's hard to do it in a single dimension. But you can help students or children learn exactly what those 3 dimensions are and how the motion or the change in motion in those dimensions occurs. So this is one thing you can do. You can pause it if you need to, you can reset it and clean up the data if you need to. However,
so similar things you will find in your data also when you will run this code or app in your mobile phone. You will find similar kind of things. Same thing I've used in mobile phone, physics tool accelerometer, which has record your center of mass trajectory, your hip trajectory, your knee trajectory, your ankle trajectory. Okay. So, and you can place in your heart also to measure your heart, monitor your heart rates by accelerometer. The baby, whether it is sleeping, whether it is suffering with some disease, whether its heart rate is more, all sort of things we can capture through this one. Okay. So still I'm giving the motivation how it is helping in the health assessments. The wearable sensors I have shown that. Apart from there is another behavior, push recovery. So it is very complex behavior where we used to perform Parker's kind of behaviors when you are jumping over different walls and when you are climbing over a staircase, down staircase. That time you require push recovery. That means your body should ever recover from external forces. Robotics application people are using widely for push recovery so that robot can recover the one. Okay. So coming back, yeah. Can you mute yourself? Okay. Okay. Am I audible, ma'am? Purnima madam, am I audible? Okay, thank you. So let us go back in locomotion and let us understand the locomotion again. By define, already I told that it is 3-stage stance phase is coming. Okay, all sort of species or animal they used to perform their locomotion. So moving from one place to another place. In this case, I'm introducing the legged locomotion with the help of leg because I'm interested to understand the human health. Okay, then we'll see also what is passive and dynamic and how optimal design we can do design and how we can model in the 3D. Okay, so these things I'm going to discuss now. The study or interest of bipedal locomotion. It is helping us to understand the biomechanisms of how human being used to walk. How we are walking. This study is helping us to understand the biomechanics involved with this one. It also helping to design the active prosthesis, artificial limbs, exoskeleton which you can wear from outside, and this one. Effect of the disease, strokes, Parkinson's, cirrhosis, all sort of. This study also help you to design the robot which can work very similar to human being because robots are nowadays working in human society and they require feature hand, leg and faces. And the entire human structure is defined for human beings, so we have to assess all sort of environment. Okay. Now the locomotion is how it has evolved. So you see that different animal has different shape of legs, they have different length of legs, their number of legs are also different. If it is quadrupedal and bipedal, if you see the human being, it is bipedal, and goat, cow are quadrupeds. Some has inward direction foot, some has outward direction foot. This is like crab, this is like your lizard, this is like dog, cow. They are straight mammal all have straight legs, but their utility is this one. Lizard has to climb over stair, stair not wall, so they have such kind of shapes, outward direction. Some are flying in this one, and there is 2 plane. From frontal direction you can see, from sagittal direction you can visualize the walk, and from top also you can see. There is 3 planes: frontal, sagittal, and top view. Okay, the shape of leg is important. All shape of legs are not equal. So there is basically 3 category of legs. One is inward direction incline, another is outward direction legs, and one is one side they are inclined. So the length is also important. All length generally in human being both leg length are equal, but generally some Animals, we have different legs. Okay, that is also. So now I'm coming and defining what is gait. It is pattern of foot placement and it is time series data. It is time series data. Okay. So you see that we have left and right legs. It is quadruped animal. Quadruped animals which has 4 legs. And already I told that there is stance page and there is swing page. Okay. Stance page when foot are on the ground. Sorry. STANC, stance page and swing page. So when foot are in the ground, that means block dirt is showing stance page and it is represented by the stance page of which leg? Right foot and left back. This is left front, left back. This is right front and right back. In this case, your left back and right back is on the ground at time t1. When you are change overing, that means your switch is move, your foot is going to change from left swing to right swing. So again, all the 4 foot will come on. This is double supported because all 4 are on the ground. So that time at time t2, all 4 are at ground. After that, once changeover has taken place, now these left front and right back are coming in the stance phase, and left back and left front is going to become swing phase. Again, take over is thing. So this is time series evolution, and that is how gait pattern is moving. Each joint has its own unique pattern. That also we can see that. And little bit understand what is legged robots, the robot which has human similar legs. So there is passive and as well active. So when you are using motor and other things, that time it is active. When you are using some potential energy or some form of energy which is converting and helping us to move, that time it is passive. So okay, so you can see the motion from the frontal direction. So you are rotating, tilting about your hip. You can see from sagittal plane, from side direction also you can visualize. To understand the locomotion and to assess the health, the ZMP TGT also important. If you are suffering with some foot problems, or maybe you have no thumb, that time you will find difficulty in the walking. Okay, and you see that this always shoe is prepared like this. The shoe is designed in such a way, and you are entering wearing shoe from here. Why? Because the ZMP TJT zero movement point on the ground is starting from here. It is moving and it is passing from here to another leg, from left leg to right leg to left leg. This way we can switch, and you can see the TJT of ZMP. That's why there is no mass in this area, because we are not taking any forces. You can see that they do not touch, and this size of small fingers, the reason is that they are not taking any pressure. This is what benefit of walking. Okay, and that is ZMP TJT to assess the human health. If any abnormality in your leg, you will find difficulty in the walk. Now, there's some research which we can do. You can generate the energy optimal walking pattern. Which can during obstacle avoidance and staircase climbing. That time, human locomotion is consuming more energy. So you can work in this direction so that you can optimal the energy. Other things, you can prepare some soaked cell on the foot or bipedal, so it can reduce the effect of energy. We have to compliance when we are designing or understanding the human joint or locomotion. That we have to see the compliance, how many degree of freedom is minimum required, that much degree of freedom we have to prepare. Now I'm telling you how we have captured the data, working data through techniques like wearable sensors, kinase sensors, mobile phone, all sort of techniques we have used to capture the data. One by one you can see that. So in this case, what is happening in this image is I'm using kinase sensor also. The one kinase sensor is placed here. This is by Microsoft. This is stereo kind of camera, and the kinase sensors are placed here. So multi-view kinase sensor I'm taking, because the human walk could be speed invariant. Our target should be speed invariant, cloth invariant, orientation invariant, from which direction you are taking. It should not matter to identify your walk. Which speed you are taking, this is also not matter. What cloth you are wearing, that also not important to understand in this case. Okay, so I'm using kinetic sensors to capture the data. Microsoft earlier, it is Studio, it will extract the scale terms values. Okay, so in treadmill, what I'm performing, different velocity of walk, like 2 km/h, 3 km/h. This way I'm going to capture the data. Okay, so you can see some video simulation of data acquisition. So the person is performing walk and he is my strengths, and he will perform the walk. Same thing, the kinetic sensor is kept in front of him. So kinetic sensor is depth camera, so which is actually capturing the depth of the person, how far it is from there, and it can help us to identify the obstacle also. The person will start walk. There is RGB camera, so it is capturing the color image also. After that, the studio camera will give you such perform way of walking. It will extract the skeleton joints. You can see that you have these red dots are joints, and it is the studio camera is capturing the joints of human being when we are performing normal walk. Okay, this is when normal walk is performed. So this behavior was exhibited during normal walk. We have traced the camera and we have received the JSON file, TASON file, which you can read. If for one sample we have sampling frequency 119 Hz, so we'll capture the data of 119 rows in one sample. If you have performed 100 times, so if one cycle we want continuous data, there should be no break in data. Till another cycle or another working activity or another sample time, I will use another continuous forms. Okay, and here I am extracting only the joints. That is what's there. Now you can see that another category of work which we have performed through this one. That is bit fast work. The person is working very fast. The person is working slowly. Very slow work is presented, and the kinetic sensor can track more than one person when multiple person are working, like corridor or railway station, airport. So occlusion also possible. That means one gate can be covered by another. Okay. So at a time it can track the 6 bodies. You can perform certain exercise, jogging, because we used to suggest exercise also based on the abnormality. It can make permanently disabled before this. We can take some precautionary measure. Simple jogging it is doing. So it is tracing the human skeleton joints. Okay. Multiple body are working, 2 person are working together. So one gate is going to cover by another person gate. That is also. And then in the treadmill, I'm performing the running. So you can see that when I'm running, you can see this also. And which kind of file you are getting, that also I'm going to show you. The file which I have captured. Like treadmill, when I was working, I have captured this data in the speed. Okay. The file which I received is JSON file, Java object is script object file. You can read the data. So as I told that this kinetic sensor can track at least 6 bodies. So the body index is 3. That means third number of body index is given to that single person. Trace status 2, we have left hand state, right hand state. Then we are reading joint by value. As human body has 25 joints, we will have 25 values first. then second, then third, and if it is sampling frequency 119 Hz, you will have 119 sample in 1 second. So joints, we are getting depth value, depth x value, depth y value, color x, color y, color sensor, camera x, camera y, camera z, orientation x, y, z, w, and then you have which number of joints, 0, 1, 2, 3, whatever, hip joint, knee joint, ankle joint, neck joints, shoulder, whatever, and the tracking status, that means perfectly capture. If it is 2, if it is 1, that means it is infer, or if it is 0, then it is not perfectly captured. So this is through kinase sensor already explained. I'll show that how using earlier techniques I've used, that is through if you see that the device which I have prepared, it has 6 potentiometer at hip joints, 2 at hip joints, 2 at knee joint, 2 at length joint, because left hip, left knee, right knee, left ankle. So there is potentiometer which is person is wearing. Once you will move, and it is attached with the these welcome this black color things. Okay, and then you have Arduino board. All potentiometer are connected through Arduino board, and Arduino board is through wired or wireless. It is communicating with the laptop, and you are capturing data. You can see that the person is walking, and we are capturing their motion. Though it was tedious, we have to carry the laptop. Other techniques in which we have used mobile phone simply. So we are performing inside laboratory. Then once we have captured accelerometer data x, y, z, so that it is giving displacement, with the help of famous robotic inverse kinematic solution, we can calculate the joint angle value also, and it can help us to work in this way. The another important behavior with this same wearable device we have used push recovery behavior. So in this case, same dash is there. Only things, we have placed the pressure sensor in the behind, and we are applying the uniform pressure over this pressure sensor, though it has small size, and the person is showing different negotiation capability in front of the pressure sensors. So the person is walking fast, slow, and this way. Okay. 1 minute, there is one call. I will get back.
Okay. This conference will now be recorded.
Okay, so you see that now what is happening, the person is walking. Okay, and we are analyzing the push recovery behavior. The person, we are applying force from behind, so we are seeing that how it is negative. If it is athletes, they have better push recovery capability compared to normal human being. We are also seeing the biometric analysis. So for this purpose, now I'm coming on the data acquisition concluding view. We have collaboration also with the Monash University, Malaysia. In this case, we are using 3D visualizers tool, by which we are trying to analyze human skeleton joints for human health monitoring, different posture stability, different walking style. They are also using IMU sensor. These are again same IMU sensor with the multiple degree of freedom. IMU sensor are placed here. Okay, hard to monitor the health monitoring. This is what, when we are using treadmill, we are placing this IMU sensor on different joints to capture the different joint. You can see left ankle, right ankle joints. So all sort of things you can do through the IMU sensor as well as kinase sensors. Okay, these are the visualization tool in which we are using skeleton joints and then dynamic quali system motion. We are analyzing the force also which direction which is coming, kinematic parameter we are concerned by which we are analyzing the human. Okay. There is another technique in which we are placing the reflexes over the body's points, placing the things from frontal plane, side plane, sagittal plane, back view. So these are reflexes are coming flashing. So from here we can identify where is the joints inside the body. So this is also technique by which we can analyze the human. So now I'm coming how what health parameter gait can assess. Okay, how it is beneficial for the analyzing different health metrics that I'm going to touch, and how you construct the body area network. Okay, so gait cycle is the time between successive contact already defined when same foot is contact in the ground. So one gait cycle begin with the reference foot contact on the ground and end with the same foot on the ground. Okay, there is three plane already I told: sagittal plane, frontal plane, and traversal plane. Okay, so sagittal plane, when we are seeing from side direction, it is dividing into left and right hemisphere. Traversal plane, when we are seeing from top, it is dividing lower and upper, and the frontal plane we are seeing, or coronal plane, when we are seeing from front. The gait data which I divided into 8 phases, like 1, 2, 1, 2, 3, 4. These are named loading response, mid stance, terminal stance. These are the stance phase, and rest is the swing phase. Okay. So already initially I have introduced you swing phase. If you are aware, the swing phase was coming for 40% of time and 60% to our stance phase. Okay. These are the different joint angle values. Like hip joints, I'm getting in the degree with respect to time for one gait cycle, almost sinusoidal curve. Again, sinusoidal for normal work. For knee joints, I'm getting one big hump, small hump, big hump, small hump. This kind of joints I'm getting. For ankle joint, I'm getting small hump and big hump. And both are inversely related. When you have big hump, that means your knee is going to bend in the swing phase. That time your ankle is least activated. And when your ankle is striking on the ground, your knee is little bit contributing. So that's why both are inversely related, knee and ankle. Both joints are inversely related. The walk could be static walk and dynamic walk. In static walk, what is happening? Your center of mass projection is passing through this support polygon which is formed by your leg. In case of dynamic walk, when you are performing, playing badminton and tennis, that time you will have that. And the position of center of mass is not falling over the support polygon which I have prepared. So maybe this is your vector A, center of mass. There is another vector B. There is angle between this. So we'll taking position of this vector over there. Okay. So during static walk, there is no extra torque is required to balance the body. But when you are dynamic, the ground action force should pass through here, but actually it is passing here. So body is momentarily unstable. So to adjust or maintain this one, you require some torque, okay, which you can calculate. You can have different ground, level ground, inclined ground, staircase, uneven grounds. Okay, so I'm not defining these terms. Step length is clear, style length is clear. Okay, so first you understand swing phase. Swing phase is that when your foot is in the air, so that's why it is moving in the shifting. Stance phase, it is straight, again it is swing, and then stance phase. So similarly, if you see that left foot and right foot, where left foot is in the stance phase, right foot is in the swing phase. When right foot is in the stance phase, left foot is in the swing phase. Only few, this much amount of time you are observing double support phase. That means both foot are on the ground in one gait cycle. This is one gait cycle, so 3 times you are getting double support phase. Rest of the time single support phase. Okay. Already defined gait surfaces. Now I'm coming how walking speed detection human health. Okay, so we know that blood pressure, breathing, body temperature, pulse provide important insight of the complexity of human health. Okay, so it used to provide various health metrics, but researcher has suggested that if I will use walking speed of the person, it can be better predictor of health issue like cognitive decline due to the neural disorder or neural dying. It is going to do posture stability for recovery. Even cardiac, certain cardiac and the pulmonary disease also can be identified, the gait walking better. So if you see the matrix, which I will show you, and that is what this mobile phone, it has accelerometer, gyroscope. Gyroscope is used to project the data angle made by the different joints, and accelerometer is giving acceleration around XYZ axis. Okay, and as a IoT application, healthcare is almost contributing 40%, 30.3%. So that's why we cannot ignore these things. And how you can construct the body area network, I'm going to tell how you can design. So nowadays, what is happening? The body can be enabled with the various sensor, ECG sensor to monitor your brain, EEG sensor for your heart, EMG sensor, muscle interaction. You have motion sensor to capture the motion values and all sort of things here. So that's why motion sensor has places in different portion. All are capturing data. It is going through your mobile phone wirelessly or wired medium through Bluetooth and Zigbee. It is going on your mobile phone, and ultimately you are placing on the cloud, either fog computing, either edge computing. In edge computing, data is private, not on internet. The device itself is capable of taking data or processing that data. In case of cloud computing, you are keeping your data over internet. That's why you are getting a little bit of privacy issue. And for computing, when you are using not using cloud directly, you are using fog, and ultimately your data is placed on cloud. So there is different panel experts. Okay, so some health monitoring system is there. They will assess your data and they will return and provide your report. Okay, you can get telemedicine, telehealth, and also. So how IoT device is working? They have sensor and actuator. Through sensor, they are sensing, preparing their planning, and then their actuator is actually actuating their muscles. Okay. So smart health monitoring is the targeted domain in which we are using this human gait analysis to prepare this one. Okay. So now how you can do smart health monitoring during IoT device? So your body area network, the person is there, it is enabled with the all sort of EEG, ECG, EMG, motion capturing sensors, enable the bodies, the person, entire body is placed. Nowadays during COVID, when doctor was not visiting in the wards to visit, and it is difficult to continuously monitor the patients. And if critical condition is there, we can observe virtually by seeing some other place through certain sensors are placed over body. If any critical case is coming, whether patient is crying, so we can see their facial expression, we can monitor their heartbeats, we can monitor their blood pressure, glucose, and all sort of various sensors. And we can see if any critical case is coming, we can immediately rush toward that particular wards. Okay, so we are actually first phase is data acquisition, sensing, transmission. So here we are acquiring data. Once data is sensed, it has noise, we have to remove, but before removing this pre-processing techniques, you have to send the data over your cloud. So for this, you have Bluetooth and Zigbee, by which you are connectors, concentrators, like mobile phone and other, it is capturing, it is stored in the cloud. So second phase is data concentrator on the cloud portion. After the data on cloud, so any expert doctor can visit you, trace your data, and can provide you reports like your blood in this reports, and they can suggest also particular treatment for you which is required very much to solve your issue. So three phases we are doing: data acquire, sensing, transmission, data concentrate. So it is involving cloud computing, IoT, cyber physical system also I'm defining. If you will see, refer this matrix, so there is different biomarkers like gait, ECG, respiratory rate, skin temperature, surface EMG, sweating, blood pressure, body movements, blood. So if you see that body movements and postures, it is helping us to identify or assess cardiovascular diseases, chronic obstructive pulmonary diseases related to your stomach, Parkinson disease, Hamilton diseases. Diabetes case not helping, but you can see that the gait is almost helping us to assess various important parameter of human health. Okay, so that's why gait is walking is concerned for study purpose. Now the last page which I'm going to discuss here, how you can build the machine learning or deep learning models, or how you can provide the autonomous models. Okay, in this case you have prior sensor data, previously capture the data, or through this data you have prepared the model. Model means it is like learning systems. You have past experience, from past experience you have learned, you have built the model, and now in future if any new data is coming, you have to predict this data or but the data in the case of healthcare, we have to always consult the clinical doctors and these things. You can see that the metrics should be accepted by the clinically. So you have sensor data, machine learning model has been there. Then you have prepared your predictor or classifier. New data is coming, it is classifying or predicting, and then you are also taking help of doctor in case of telemedicine, teleoperation, teleconsultation. So IoT in healthcare is becoming the heterogeneous computing. Somewhere you are using wireless channel, somewhere you are using fog computing, somewhere you are using simple edge computing. So these kind of different computing, somewhere you are using body area network. Okay, so communication system, app and device that connect patient or health provide to diagnosis. So that is what we are going to do. It is enabling under telehealth umbrella, telemedicine consultation, monitoring, surgery, remote medical education, telehealth data science. It is helping. Then we can map this problem at a cyber physical system also. Okay, so we have a embedded kind of device in which we cannot update our data, but in case if we use cyber system, cloud and other things, center which the data is available for every person, and through HMI they can access this data of healthcare, then it is becoming the cyber physical system. Okay, that is what I have used kindness sensor capture. It has microphone array to record your speech, it has vision camera, it has LED depth sensors, and this one we have traced for different walking activity like walking very slow, running, walking on toe, walking fast, walking different patient data. We are currently working on the stroke survival data, patients data, so that we can help them. And kindness sensor is especially using for body skeleton detection. They can utilize for gestures like Indian Sign Language and other and speech recognition. And the kindness sensor is giving these 25 5 joints 0 to 24. I have considered only 12 joint to 19 joint. Hip left, knee left, ankle left, foot left data, hip right, knee right, ankle right, foot right. Because I was interested in the walking, that's why I have considered this category of data. Okay. So finally, now what we have collaboration with the Hosai universities. So we are capturing for human being data, whether it is uploaded, multiple people are working, whether it is impaired person like elderly subjects whose walking is degraded or impaired. So we are collecting data, we are reconstructing through mathematical techniques, through curve fitting or other things to pre-process the data, because a lot of zero values and other is coming. We have used data smoothing, data averaging, data normalization techniques, and after that it can be utilized for rehabilitation, like different exercise you can suggest for the patients or the sports person who are suffering with the walking. And this one we can also utilize for stability analysis of robot walks, and we can also use for simple analysis of human health monitoring. Okay, so these are some publications which you can refer related to this one. And we are using for generating of human walking trajectory using some controller. Clinical aspects also, IEEE sensors, IEEE tensions, whoever is there. This is clinical human gait classification using ALM techniques is done. Okay, so for this time I'm finishing here my talk, and now let us conclude this talk. What I have done, we have study about human locomotion walking, and the walking is very important because it is using to monitor your health. It is assessing your health. The walking data can be utilized for robot walk generation. The walking data can be utilized for the development of prosthesis leg, for design the exoskeletons. Okay, and after that we have mapped this data with the IoT devices. Okay, so I can show one demonstration, which you can see that how you can design or assess. This is OpenSim software. Okay, I'm loading particular model. Suppose I'm going to model this gait 25 degree of freedom. You can see that this is model name is 2354. This is 23 degree of freedom and 54 muscles are there. Different body joint, pelvis, femur, tibia is there. Joints are your ground, hip, left hip, right hip, ankle, all the inside there. Now I will provide the motion here. Once motion you will provide, the body will be able to walk. It is continuously working. Okay. You can assess the health. You can see that how different muscles activation is happening. You can see from different planes: top view, front view, side view, back view. After that, you can also see that how TJT are generating. IMU, inverse kinematics, everything you can see. You can see the sensor data also. You can see the plot of different joints. Hip joints, I am going to see how hip joints curve is coming. Hip joint, I am going to see hip flexion. So hip angle X, I am going to just coordinate time with respect to time how I am getting. So you can see that for hip joints, I am getting this kind of curve for one gait cycle. The person is walking, I am getting here. Similarly, you can get for knee joints. Knee and ankle also I can ignore. Both I am adding with respect to time. Now you can see that three joints: hip joints, knee joints, and ankle joints. In ankle, you have a small hump, big hump. Knee joints, small hump, big hump, small hump. Knee joint, small hump and big hump. This is hip joint. You can assess your health also with the day-by-day basis, whether any abnormalities coming, things you can disable certain joints. Okay, you can disable the muscles also. We can hide. You can see the motion value is how it is changing different joints. Different force muscles I can convert muscles. There is each joints you have muscle. You can disable the muscles also. I have hidden the muscles. Now we are just getting skeleton joints. You can see. Okay. Okay, with this I will close my session and I will open for question answering. If you have any question answer, you can ask from me regarding software. You can write in chat box also. I'm looking in the chat box. Okay. Or either directly you can ask. Any doubt regarding software, how human monitoring is happening? Anyone having any doubt? Yeah.
If you have any doubts, how you can ask? at least through the chat box. You can post your queries.
Hello, sir. Good morning, sir.
Yeah, good ma'am. Good.
So the software is Open Simulator, sir.
Yeah, OpenSim. OpenSim, it is OpenSim.
That means, is it open source, sir?
It is open source. You can easily, I can show you the screen. How you can download. You just require institute login not. They will ask the permission which purpose you are using. OpenSim. OpenSim software is there. You can go latest version down because this is for Python. That is sorry, Linux as well as Windows. You can go here. You just do login. Okay, and you can download. You can solve inverse kinematic problem also here from download section. If you go download link here, for Windows it is giving OpenSim 4.3, Windows 56, and Mac OS it is giving different. Okay, from here you have certain tutorials. Once it is installed, also OpenSim. It is here. You can go in the library. Okay, some JDK OpenSim. There is tutorial available. You at least try to solve these tutorial, 3 tutorials. Images tutorial 1 and 2, 3. It is given tutorials. Everything is given how it is working. Okay, how you can disable the things. You can go. That is OpenSim. And in future you can refer my work, and I have extensively worked in this direction. Okay, so you can pursue my work and related to human activity recognition, human walking activities that I'm sharing in the chat box. Okay, I'm sharing my mail ID also if you are finding anything, because I'm working in the post stock data also, stock patient data from the AIMS Bhopal also we are protecting. Okay, so any human activity recognition, human walking data, robotics application, or human health monitoring, different publication, you can see that we have recent 2 or 3 publication for publish. People see that recently in 2013, like wearable sensor-based pattern mining for human activity recognition. This is heterogeneous computing model for the post-injury human walking pattern restoration and posture stability of human skeleton. It is published in the expert system. Okay, so different work has done. You can see that speed, cloth, and the 4 invariant gait walking